Hey everybody! Today we're going to be talking about inheritance and I'm going to cover chapter 10 and let's begin. Here are all of the main topics. You can pause to read. I think this is going to be a two-part video and I'm going to cover half of these topics today and half of these topics you will see on our live lecture. So we covered inheritance a little bit in PLD 101, so let's just have a quick reminder of what it is. So inheritance comes from the idea that every our real life object is typically just a specialized version of a more general object. I give you an example with vehicles and, for example, car, plane, automobile, motorcycle, train, and stuff like that. So vehicle is going to be the general object because it will take us from point A to point B. However, there are all of these different specialized versions of a vehicle. Well, that is where inheritance comes in. In this example that the book gives us in this class, well, they want to focus on the term insect. The term insect is just going to describe a general type of a creature that has numerous various characteristics, right? However, different insects will have different more specialized characteristics added to them. However, all of them will share just some general qualifications, general characteristics. So, for example, we have two different insects. One is a grasshopper that can jump really high, and another one is a bumblebee that has a stinger and can fly, right? They're both insects, however, they both have their own special characteristics. Here is how this relationship will look like in a diagram. So we have an insect right here, we have an insect, and then both of our bumblebee and our grasshoppers, they come from an insect. So as you can see here, insect will contain general attributes and methods that are going to be shared by all of the insect, both bumblebee and grasshopper. However, bumblebee will have its specific characteristics that grasshopper will not have, and the same way around. Grasshopper will have special attributes and methods that bumblebee will not have. So what we call the class that's going to be insect, we call that a superclass. So insect, since it's higher overall, insect is going to be the superclass. However, all of these classes that are going to branch from insect are going to be called the inherited classes. Another way that we can look at inheritance is with the help of a is-a relationship. So as I told you, grasshopper is a insect. So this way you know that insect is a superclass and grasshopper is going to be the inherited class. So inheritance in Java is used to create that relationship between classes. And let me explain a little bit more and introduce you to a couple more terms. So inheritance involves a superclass and a subclass. And as I told you just now, just think of subclass as a class that inherits the superclass. So for example, in our scenario with the grasshoppers and an insect would be the superclass, and grasshopper and bumblebee would be the subclasses of the superclass insect. Sometimes you will also hear the superclasses being called base classes and subclasses being called the derived classes. Also, another way to look at this as to think of a parent class and a child class. So the parent class is a superclass that gives all of the general qualifications and general characteristics to all of their children, aka subclasses. Now let's dive deeper into the actual coding part in Java. So the concept of inheritance will help us to make sure that all of our classes that are considered the subclasses, they will inherit all of the fields and methods that we wrote for the superclass, and we will not have to rewrite any of those. So that just saves us time, saves us our money, saves us our energy. So you do not have to rewrite any of the fields and methods. If your subclass will inherit a certain superclass, that way you do not have to rewrite any of those again. But there is a keyword that you need to use that's going to tell your computer that you want this, for example, this final exam to be the subclass of the graded activity, and that word is extends. And this is the format how you will do this. You would put public class, the same definition as you always do when you're writing your class. Public class, name of your class, then the keyword extends, and then whatever class you want to extend or inherit. Now let's look at this UML diagram of two classes. We have a superclass graded activity, and we have the final exam class that extends our graded activity class. So let's see what fields and methods the graded activity has. So graded activity has a variable score that is a data type of a double, and then it has a couple of private methods. Public methods graded activity, that is a constructor, then public methods set score, and get grade. So basically two getters for score and the grade, and one setter for score, and one constructor that's called graded activity. Now our final exam class, it will contain all of these already, and we do not have to rewrite them. We just have to show with an arrow that our final exam inherits the graded activity class. So all of these methods and variables that graded activity has, our class final exam automatically has already. We do not even have to name them, as long as those attributes are non-private. So the only difference is that this score variable is not going to be passed down to the final exam because it is private. And how can I tell that it's private? Because there's a minus sign in front of it, and minus stands for private and plus stands for public. But then at the same time, you can see that in final exam, we're adding a couple of our own variables, which is num questions and num missed, and our own public methods. Final exam, which is a constructor, then get number of questions, get number missed, and get points each. So just a couple of getters and a constructor. Now let's focus more on the private fields of the superclass. So every member of the superclass that is marked private is not going to be inherited by the subclass. The main keyword is not going to be inherited. It's going to exist in memory when your object is going to be created. However, it can only be accessed by the subclass by the public methods of the superclass. So with the help of getters and setters. Now, any members that are marked public are going to be inherited by your subclass and can be directly accessed from inside of your subclass. Now, whenever you create an object of your subclass, all of the private methods of the superclass are going to be available to you through the subclass object, this is the way how you would use it. You would create a object called exam in this case, and to set any values to our private fields, we will use them through our object exam.setScore 85, exam.getScore. So this is a setter for score, this is a getter for score. However, all of the non-private methods and fields are going to be available in the subclass just by stating the method name. Now, any of the constructors that are made, they are not inherited. However, when your subclass is first just created, then your superclass default constructor is going to be executed first. However, you can call explicitly the superclass's constructor, but you have to use the keyword super. So if you want to call your superclass's constructor inside of your subclass, you will have to use the keyword super. Now, however, if your superclass has a parameterized constructor, which just means that it has some parameters and some values that you can send into your constructor, then your superclass either has to provide a no argument constructor too, or your subclasses must provide a constructor, or your subclasses must call the superclass constructor specifically. and those calls to the superclass constructor should be the first Java statement inside of your subclass constructor. Now let's talk about methods, right? Remember how we talked how methods can have the same names and have the same headers, which might be a little bit confusing. However, when it comes to inheritance, the only thing you need to know is that if you have two methods that have the same name, but one is located inside of the superclass and the other one is located inside of a subclass, the subclass method will override the superclass's method. And that is where the term method overriding comes from. And let me show you an example. As you can see here, we have a class graded activity, which is a superclass, and we have the curved activity, which is a subclass. However, both of these, they have a method called setScore, one right here and one right here. So this method setScore will override the method that exists in graded activity, because this setScore is made specifically for the class curved activity. So whenever we use a setScore class inside of the curved activity object, this is the setScore that's going to be used. So the subclass's setScore is going to be used instead of the superclass's setScore. Now let's recall that our method's signature consists of the method's name and any data types that method's parameters have in the order that they appear. So you should have seen it on the last slide. However, if we want our method to override the superclass's method, it must have the same signature, to a T, the same signature as the superclass's method. Another thing that you need to know, the override notation at override has to be used just before the subclass method declaration. It's gonna let you know if your compiler couldn't override the method. It's gonna tell you that this is where the error comes from, because it couldn't override the superclass's method. However, you can still call the superclass's methods from inside of your subclass. The only thing that you need to know is use the keyword super in front. This keyword super will let your computer know that you want to use the superclass's method instead of the subclass method. Now, another thing is overriding versus overloading. I know two different terms. Well, overloading is when your method has the same name as one or more methods, but the signature is different. And we just recalled what signature is. However, overriding happens only when two or more of these methods, they have the same signature. However, both overloading and overriding can happen in an inheritance relationship, but overriding can only happen in an inheritance relationship. So overloading can happen in any other relationships. However, overriding can only happen in an inheritance relationship. If you do not want your method to be overridden, you have to use the keyword final in front of your method data type. So in this case, if we do not want our subclass to override some superclass's method, we have to use the keyword final. If your subclass will attempt to override that final method, your compiler will generate an error, and that just helps you to ensure that certain superclasses methods are used by subclasses, by those subclasses, rather than the modified version of those methods. Now let me introduce you to the third access specification that Java has, and that is protected. Well, before we were not familiar with protected just because we didn't need to use it, but in the case of inheritance, protected comes in. Now, why would we use that? Well, because if you specify any field or any method as protected instead of public or private, that will tell your computer that these fields can be accessed by any methods of a subclasses or any methods that are in the same package as that class. So let me show you what it looks like. you will simply just use the word protected instead of private or public. Well, public for fields, it's not recommended. I do not recommend that you use that. We either make our fields private or protected. However, protected is somewhere in the middle between private and public. And protected just will make us help us make our fields accessible only by those subclasses that are inherited and nothing else outside of the scope. Now, here is a little table that might help you understand the differences between public, protected, and private. You can pause to read this. And this is where we are going to stop our first part of chapter 10, talking about inheritance. Now again, let me know if there are any questions. I would love to explain to you this information more if you need it. And yeah, hope you enjoyed. Bye.